Get everything installed?
Alright, so let's dive into some of this more technical material here. So in chapter 2, there's really two big goals. The first one is to understand the fairly simple things about variables and types and declarations, and that's what we've seen in sections 2.1.
Looks like you have it.
Okay. It hates me. Okay, fair. Wait a minute. So that's what we do in sections 2.1 to 2.3. And then we're going to go on and understand what classes and objects are and how to call methods. And I need to jump into that a little bit right away so that you have the tools that you need for the homework. So let me quickly go over what's in the first couple of sections. And so there's this concept of what's a type. We've seen a number of things that have types, like a number like 13 has a type that's called int in lowercase with a lowercase I. A string like hello world has a type string. And then the only other object that we've seen so far is system.out. And take my word for it that system.out has the type print string. That's just the name of the thing. In the homework, you're also seeing some other things that have the type rectangle. Oh, come on. Give me a minute here. Why the heck would this right? Not nice. Oh, it hates me today. I might have to. Yeah. Okay, so I'll just go to plan B. So you have these types. We have a type rectangle. Plan B doesn't look as pretty enough. And so those are types. And whenever you want to declare a variable in Java, you have to declare a type with it, as we'll see in the next slide. I want to go into these declarations. I'll come back to this in just a minute. Hang on. So here we have a variable declaration. And so when you look at a variable declaration, over here, you're going to see the name of the variable is greeting. Before that is the type. And behind that is the value. And that pattern is always the case in Java. You have type, name, and then an equal, and then the value. So here we're making a string greeting that is hello world. Here we're making an integer width that's initialized with 13. Type, name, value. Anytime that you want to declare a variable in Java, you have to say what its type. So later we're going to see a declaration where it says rectangle, box equals, and then something on the right-hand side that says what the value is. Type, name, value. So variables, once you define a variable, you can use it, just like in mathematics. Over here we defined a variable greeting and said it's hello world, and then later on I can use it. The whole point of using variables is to give a name to some quantity so that you can use it later. And just use your intuition from mathematics. In math you introduce variables x, y, volume, size, whatever, so that you can use them later in other formulas. And it's the exact same thing in Java. The only difference between math and Java is that in math, kind of everything that you've seen is probably like a number. And in Java, we have many more types. We have numbers, of course, and then we have these strings and rectangles and other what's called objects. So we have more kinds of things that we can manipulate. Now, going back to number types real quick here. In Java, there are two kinds of number types, which is kind of an implementation artifact. It turns out that floating point numbers, because you have the fixed point and the fractional part, are kind of more expensive to store. And so therefore, Java distinguishes between whole numbers or integers and floating point numbers that are given the name double. Now, why the heck are they called double? Because 50 years ago, when memory was very, very expensive, people stored floating point numbers in a type called float. And but float really only held very few digits. It held like 6 or 7 digits and was not enough for most computations. And then say, well, if you really need that extra capacity, then you can use doubles. Nowadays, memory is much, much cheaper. And so people don't care about floats anymore because they're just not that useful. And we use the double type for everything. And it's just unfortunate that they have such an unnatural name. So it would be nicer if doubles were called floats, but they're not. So doubles are floating point numbers, integers are integers. And any time that you declare a number, you have to ask yourself in your mind, can this number be a fractional number? Or is it always going to be an integer? So for example, if you have a price of something, even though right now that price might be $10, maybe later it might be $10.25, so you would use a double for that price. But if you have a counter, something that counts how many people have entered a room, you would use an integer because it's kind of hard to have fractional. Well, I guess you could, right? If you wanted to model fractional people in a room, then you would use a double, but normally you would use an int. So whenever you declare a number, you have to make that choice, fractional or integer, and then you use double or int for that. What if you always use double? Actually, not very many things are going to go wrong. So you could do that for a while. And the only thing that might go wrong is that you might have some round-off errors, and we'll talk about that later. So just keep in mind we have 2 number types, and we have a whole bunch of other types. Numbers are not objects, and what that means is, if you remember, let me write this down from last time. We've not really seen many objects. You've only seen one object, and that was system.out. And if you look at system.out println something, then you'll recall that I said that this is an object. This thing is what's called a method. That's a fancy name for a function. And these things were the parameters. And the way that you call a method is you have the object, you put a dot, you put the name of the method, you put parentheses, and you put the parameters inside.